To understand odds ratios, we must start with the concept of an odds. The term odds is commonly used in sporting events. We may read that the odds are 3 to 1 against a particular horse winning a race, or that the odds are 20 to 1 against Spain winning the next World Cup, or that the odds are 1 to 2 that the New York Yankees will reach the World Series this year. When we say that the odds against a given horse are 3 to 1, what we mean is that the horse is 3 times more likely to lose than to win. The odds of an event are easily calculated from its probability of occurrence. The odds can be expressed as P, the probability that the event will occur, divided by 1 minus P, the probability that the event will not occur. In our horse race example, if P denotes the probability that the horse will lose, then 1 minus P denotes the opposite probability, that the horse will win. So if the probability that the horse will lose is 0.75, the probability that the horse will win is 0.25, and the odds are 3, or 3 to 1. In the Haitian Resort Case Control Study, recall that the event of interest occurs if a study subject ate raw hamburger, and if so, we say this subject is exposed. The estimated probability of exposure for the cases was 0.46. So the estimated odds of being exposed for cases is 0.46 divided by 1 minus 0.46. Similarly, the estimated probability of exposure for controls was 0.21. So the estimated odds for controls is 0.21 divided by 1 minus 0.21. The estimated odds ratio for these data is the ratio of the odds for cases divided by the odds for controls, which equals 3.2. How do we interpret this odds ratio estimate? One interpretation is that the exposure odds for cases is about 3.2 times the exposure odds for controls. Since those who ate raw hamburger are the exposed subjects, the odds that a case ate raw hamburger appear to be about 3.2 times the odds that a control subject ate raw hamburger. Odds ratios, like risk ratios, can be greater than 1, equal to 1, or less than 1. An odds ratio greater than 1 says that the exposure odds for cases is larger than the exposure odds for controls. An odds ratio below 1 says that the exposure odds for cases is less than the exposure odds for controls. An odds ratio equal to 1 says that the exposure odds for cases and controls are equal.